before you see those changes. So, you know, frankly, I would be very surprised if substantial oxygen drawdown was documented close in, just because the microbes haven't had enough time to impact the signal that you see. So I don't think the two data sets are inconsistent. They're just, you know, if you make measurements at one place, as opposed to doing a transect and looking how the system evolves over time, and that you achieve by looking away from the site, you're not going to see oxygen drawdown if you look close to the wellhead, and we didn't see any up there either. In fact, I was communicating with some folks on the Brooks McCall just yesterday, and the question I got was, where's the oxygen drawdown? We're not seeing any. And I wrote them back, well, where are you exactly? And they said, oh, we're about 3 kilometers from the wellhead. I said, well, of course you're not going to see any there. You know, I'd be shocked if you saw any there. You need to get further out, and this is how you do it. You track the plume by doing 2-mile, you know, drops of the CTD rosette. You know, track the plume with distance away, and when you hit the 8 to 10 kilometer mark, you're going to start seeing substantial drawdown in oxygen. And I don't know whether they're going to do that, because their task is to track this dispersant in the water column, and to do that, they need to be close in where the concentrations of dispersant are still high. So, because you're not going to find low oxygen water where you find the highest concentrations of dispersant. You're going to find low oxygen water where the dispersant's already been quite diluted. Does that answer your question?
Yes, it does. Thanks very much. That's really helpful.
Yep.
So, Dr. Joye, Phil Kithill with that motion. On that same topic, the low oxygen zones further away beyond 8 kilometers, is anyone measuring what the oxygen levels are 10, 15, 20, 30 kilometers away, or is that part of your August cruise?
We did that, and so did the Pelican cruise scientific party, and we got about 25 kilometers out. I believe the Pelican was even further than that out, and they measured. They got oxygen down to about 2.5 milligrams per liter, maybe even lower than that, but I'm not certain. So the further out you go, the older the water, the more oxygen depletion that you tend to see, and that's not surprising, because as that water ages, as the microbial community tears down, you know, the oil and gaseous hydrocarbons, oxygen is going to be drawn down too. So, in fact, the water that we saw with the highest loads of dissolved gaseous hydrocarbons tended to have the least oxygen depletion, because again, it's very young water. So, I don't know with respect to other, you know, cruises who's made those measurements far out. I think some of the Thomas Jefferson stations were pretty far out, and I know the Gunther stations they did some stations that were pretty far afield from the well site. But I haven't seen all the data from either of those cruises, so I can't speak to how, you know, low the oxygen got in the grids that they did.
Thank you.
I've not heard you call it a dispersant before. Why are you calling it that?
That's the terminology that was used in the email to me yesterday from the guy on the Brooks McCall, was that our job is to track the dispersant plume. So apparently there is one. I don't know anything about it other than that's what it was referred to in this email. Because, you know, when there was a series of emails that went back and forth, and it was basically, where's the low oxygen water? We're looking for it and we can't find it. And in fact, I think there was even an email that preceded that said there is no low oxygen water, and my response was, well, where are you exactly? And then it got into this, we're pretty close in, and, you know, well, we can't really go out because our job is to track the dispersants. And, you know, clearly there has to be a dispersant plume. I mean, the dispersant's being jetted into the, you know, it's traveling with the oil and gas, and if there's a subsurface plume of oil and gas, there's going to be subsurface features of dispersant as well. What they're trying to do is see what the concentrations of dispersant are, I gather. And, you know, they'd like to see whether there's an oxygen effect associated with this feature, but they're not seeing any oxygen effect that close in.
How would the plumes look different if there were no dispersants?
The question, for those of you on the phones, was how would the plumes look different if there was no dispersant? I suspect that the gas plumes would be essentially the same. There might be more oil in the plumes because of the dispersant, but really there's no way, this is not an experiment that's been done before. So, and the dispersant application at the seafloor started pretty early on in this spill, so there is no before and after. Essentially, the biggest difference is probably the fact that, there's dispersant in the plumes because dispersant's being added at the bottom. But I really believe the gas would be in the deep water no matter what. It's independent of the dispersant. So the dispersant may be altering the distribution of oil, but that's effectively what it's doing, what it's changing relative to what the situation would be naturally, well, as a result of the spill itself.
And no sense, are you going to have a sense of what
Call from 407-841-798.
Say that again?
You know that you're seeing microbial community double in size in 24 hours, but what about 48 hours or 96 hours?
Well, we only did 24-hour experiments. The question was, how does the microbial community change after 48 or 96 hours relative to 24? We only did 24-hour experiments because we were trying to process as many sites as we could, and we only had a limited number of bottles, so we were recycling through them as quickly as we could. We don't even really have a sense of what the variability is in 12 versus 24 hours at this point. I picked 24 and hoped that it was a good number, and it seemed to be a pretty decent number. I doubt very seriously that the population can sustain growth like that for longer than a few days. I mean, there's this sort of rule of sevens. Once you've doubled a population 7 times, you tend to run out of something critical, whether it's iron or nitrogen or phosphorus. 7 doublings is about the limit. So, if they're doubling every day, or almost doubling every day, then within about a week or so, they're going to run out of something that they need. But we really don't know. I mean, Malitz is setting up an experiment next week to do a time series incubation, and to sort of see how things change when you add methane or oil or methane and a mixture of higher alkanes to the water, and how fast the nutrients get drawn down and how fast the respiration rates change and the cell numbers change. And until we do that experiment, we really aren't going to know the temporal evolution of the system.
How is that likely to change if, as we're hearing now, there's some possibility that the leak gets stopped or slowed in some fashion?
Well, if you shut off the flow, basically you then just have water that's been inoculated with oil and gas, and the community is moving with that water, and it's going to metabolize the stuff that's dissolved in the water and suspended in the water. With the leak over the past almost 4 months, you've had this constant input, and if you shut that off, then it'll be processed. Again, we really don't have a good feel for how long it's going to take the microbial community to process all of these materials. And one of the things that I'm really curious about, it extends beyond the oil and gas, but the dispersant itself, because this is a chemically pretty complex dispersant. It's not just one compound. It's a multitude of different compounds, that some of which can be biodegraded into other compounds, which may be more or less toxic than the parent compound. And what are the impacts of those different compounds on the microbial community and activity of those organisms? We really don't know, and that's something that I hope we have the opportunity to look at in lab experiments, because I think we really have to worry about that just as much as we worry about the oil and gas, because that's another feature of this spill that is going to take some unknown amount of time to be removed from the system.